Hey everyone, ready to shrink down to the subatomic level?
Sounds fun.
Today we're going deep into the fascinating world of atoms,
Okay.
their structure,
Right.
and how scientists like Ernest Rutherford revolutionized our understanding of matter.
Should be interesting.
Our guide for this deep dive is an excerpt from a book all about Rutherford,
Okay.
especially his discovery of the atomic nucleus
Right.
and the bizarre world of radioactive decay.
Cool.
What I'm really excited to dig into is not just the science itself,
Yeah.
but the process of discovery. How did scientists even begin to figure this stuff out?
It's like a detective story.
Oh,
Piecing together clues and following the evidence to unveil a hidden world.
I like that.
It all starts with a really simple question.
Which is?
What is the universe made of?
Okay, so let's go way back.
Okay.
We're talking ancient Greece, right?
Right.
Philosophers like Democritus were already tossing around the idea of atoms.
They imagined these tiny indivisible particles as the fundamental building blocks of matter.
Interesting.
They called them atomos, meaning uncuttable.
But their ideas were, well, more
Awesome.
philosophical than scientific.
Right.
Fast forward a couple of millennia, and scientists are finally starting to get a handle on atoms. They knew they existed,
Right.
but their inner workings remained a complete mystery.
It's like trying to understand a complex machine, like
Yeah.
a watch, without ever being able to open it up and look inside.
That's a great analogy.
Thanks.
And that's where J.J. Thomson enters the scene.
In the late 1800s,
Oh,
he discovered the electron,
okay.
a tiny negatively charged particle.
So that was a huge step forward.
Oh, yeah, absolutely.
But the question remained, how are these electrons arranged within the atom?
Right.
So Thomson came up with this model
Yeah.
called the plum pudding model, right?
Exactly.
So can you explain that for us?
Yeah, so it was a pretty intuitive model for the time.
Okay.
He envisioned the atom as a sphere of positively charged stuff, with the negatively charged electrons embedded in it, like plums scattered throughout a pudding.
Okay, I can kind of picture that.
Yeah, makes sense.
But then along comes Rutherford and totally rocks the scientific world
Oh, yeah.
with his gold foil experiment.
This is where things get really mind-blowing.
Okay, I'm ready.
Rutherford, along with his colleagues, Geiger and Marsden,
Okay.
decided to probe the atom by firing tiny projectiles
What kind?
called alpha particles
Okay.
at a thin sheet of gold foil.
And what were they expecting to happen?
They expected these alpha particles to just sail right through the foil, like bullets through tissue paper. Based on the plum pudding model, they thought the atom's positive charge was spread out diffusely.
Okay.
So the positively charged alpha particles wouldn't encounter much resistance.
Makes sense.
But that's not what happened at all.
Oh.
This is where the aha moment hits.
Okay, tell me more.
What Rutherford and his team observed was shocking. While most of the alpha particles did pass straight through the foil as expected,
Right.
some were deflected at sharp angles,
Wow.
and a small number even bounced straight back.
What?
It was like firing a cannonball at a sheet and having some of them ricochet back at you.
I can only imagine their reaction.
Yeah, it was a real head-scratcher.
What could possibly explain those particles bouncing back?
That's the beauty of science.
I love that.
Unexpected results often lead to the most groundbreaking discoveries.
I agree.
This unexpected result forced Rutherford to rethink the entire structure of the atom.
So how did he explain those rogue alpha particles?
His explanation was nothing short of revolutionary.
Okay. Lay it on me.
He proposed that the atom's positive charge wasn't spread out evenly,
Okay.
but was concentrated in a tiny, incredibly dense central core.
Interesting.
He called this core the nucleus.
So instead of a diffuse pudding,
Right.
we have a tiny, incredibly dense nucleus at the heart of the atom.
That's why.
And those alpha particles that bounced back were the ones that happened to hit this nucleus head on.
Exactly.
Boy, that's amazing.
It's like trying to roll a marble across a room full of pillows.
Okay.
Most of the time it'll roll right through.
Yeah.
But if it hits a bowling ball hidden in the middle of the room, it'll bounce right back.
Okay.
That bowling ball is like the nucleus.
Wow.
A tiny but incredibly dense concentration of mass and positive charge.
Okay, that makes sense.
Yeah.
But just how small are we talking about here?
It's truly mind-boggling.
I bet.
If we scaled up the atom to the size of a football stadium,
Okay.
the nucleus would be like a single pea sitting at the center of the field.
Wow, a pea in a football stadium.
That's right.
And that tiny pea holds most of the atom's mass.
That's right.
This realization was a game changer.
Absolutely.
It completely overturned the prevailing view of the atom and laid the foundation for a new era of physics.
A new era.
The exploration of the atomic nucleus.
This discovery must have sent shockwaves through the scientific community.
Yeah.
Was it immediately accepted, or did Rutherford face resistance to this radical new idea?
It wasn't all smooth sailing.
Ah.
Well, Rutherford was a visionary,
Yeah.
but even visionaries can meet with skepticism.
Sure.
Some scientists were hesitant to accept such a radical departure from the established model,
Uh-huh.
but Rutherford's evidence was compelling.
Yeah.
And his careful analysis of the scattering patterns of the alpha particles
Yes.
provided strong support for his nuclear model.
It was very convincing.
So Rutherford unveiled the atom's nucleus,
Right.
this tiny, dense core of positive charge.
Yes.
But what about those electrons?
Good question.
Where do they fit into this new picture?
That's a great question.
Yeah.
And it leads us into another fascinating chapter of Rutherford's story.
Okay, let's
And another groundbreaking discovery. Radioactivity.
Ah, yes. I've heard of that,
Yeah.
but I'm a little fuzzy on the details.
Well, it all started with another accidental discovery,
Really?
this time by a scientist named Henri Becquerel.
I've heard of him.
He was studying uranium salts
Okay.
and noticed that they were emitting some kind of invisible rays that could fog photographic plates,
Oh, wow.
like X-rays, but from uranium.
Interesting.
These mysterious rays were a complete enigma at the time.
Yeah, I can imagine.
They seemed to be coming from the uranium itself, not from any external source of energy.
So that was something entirely new.
Oh, yeah, definitely.
The spontaneous emission of radiation from certain elements.
It was revolutionary.
And what did Rutherford have to do with this?
Well, Rutherford, being the brilliant scientist, he
Yeah.
was jumped right into this new field of research.
Of course.
He devised ingenious experiments to study these radioactive rays
Okay.
and discovered that there were actually 3 different types of radiation being emitted.
Oh, wow.
He named them alpha, beta, and gamma rays.
So we have these 3 different types of radiation, each with its own personality.
Yeah, they're all unique.
What did this tell Rutherford about the nature of radioactivity itself?
This is where the real mind-blowing part comes in. I'm ready.
Rutherford realized that these radioactive rays were actually particles being ejected from the atom's nucleus.
Oh, wow.
This meant that the atom, which was once thought to be indivisible,
Right.
was actually undergoing spontaneous transformations.
So atoms aren't static?
Nope.
They can actually change into other elements?
Precisely. It was a revolutionary concept.
Wow.
Like alchemy on an atomic scale.
That's crazy.
Rutherford's work, along with the groundbreaking research of Marie and Pierre Curie,
Okay.
laid the foundation for our understanding of radioactivity and its profound implications for everything from medicine to energy production.
This is incredible.
Pretty amazing.
We've gone from ancient Greek philosophers speculating about atoms
Yeah.
to scientists like Rutherford actually probing their inner workings
Yeah.
and discovering that they're not these static, unchanging things,
Right.
but are capable of spontaneous transformations.
And shooting out all sorts of particles.
It's like the atom itself came to life right before their eyes. It really is quite something.
Welcome back. Last time we left off with Rutherford's groundbreaking discovery of the atom's nucleus
All right.
and his exploration of these mysterious radioactive rays.
Uh-huh.
It's mind-blowing to think that these tiny atoms, the building blocks of everything we see and touch,
Yeah.
are capable of spontaneous transformations, shooting out particles like tiny cannons.
It really challenges our everyday perception of matter as solid and unchanging, doesn't it?
Absolutely.
Rutherford's work opened up a whole new world of atomic phenomena,
Okay.
a world where elements could transmute into other elements, releasing energy in the process.
It almost sounds like alchemy turning lead into gold.
Right.
But this is real science, not magic.
Exactly.
And it had huge implications. Right?
Absolutely. Rutherford's work on radioactivity laid the foundation for a whole new field of science. Nuclear physics.
And it wasn't just theoretical.
Nope.
It had practical applications that would change the world forever.
For sure.
Okay, so let's talk about those applications. What were some of the ways Rutherford's discoveries impacted the world beyond the laboratory?
One of the most significant impacts was in medicine.
Oh, really?
Remember those radioactive rays Rutherford was studying?
Yeah.
Well, it turns out they could be harnessed for both diagnosis and treatment of diseases.
Wait, so those rays that seem so mysterious and even dangerous
Yeah.
could actually be used to heal people?
Exactly. For example, X-rays,
Okay.
a form of high-energy electromagnetic radiation
Yeah.
similar to gamma rays,
Right.
revolutionized medical imaging.
In what way?
Suddenly, doctors could see inside the human body without surgery,
Wow.
allowing them to diagnose fractures, infections, and even tumors.
That's incredible. It's like having a superpower, being able to see through flesh and bone.
I know, right?
And what about treatment? How were radioactive rays used for that?
Well, it turns out that certain types of radiation can actually kill cancer cells.
Oh, wow.
This led to the development of radiation therapy, which uses targeted beams of radiation to shrink tumors and treat various types of cancer.
So something that initially seemed so mysterious and potentially dangerous was actually harnessed to fight one of the most feared diseases.
It's pretty amazing.
It's a testament to the ingenuity of scientists to find ways to use these discoveries for good.
Absolutely. And it's not just medicine. Rutherford's work also had a profound impact on our understanding of energy.
Okay, how so?
Remember how he discovered that radioactive decay releases energy?
Yeah.
Well, that realization opened up the possibility of harnessing nuclear energy,
What exactly is that?
the energy stored within the atom's nucleus.
So we're talking about nuclear power plants.
Yes.
The ones that generate electricity by splitting atoms.
You got it. The idea of nuclear power was incredibly exciting and terrifying all at the same time.
Oh.
In what way? It held the promise of a clean and nearly limitless source of energy,
Right.
but it also came with the specter of nuclear weapons
Uh-huh.
and the potential for unimaginable destruction.
This is where the ethical implications of Rutherford's work really come into play, right?
Well, it's a huge issue.
He essentially unlocked a force of nature that could be used for both creation and destruction.
It's a complex issue, and one that Rutherford himself grappled with.
I can imagine.
He was a scientist driven by curiosity,
Of course.
but he was also a human being acutely aware of the potential consequences of his discoveries.
From what I've read, he seemed a bit conflicted about the whole thing.
Yeah,
He initially dismissed the idea of practical nuclear power,
right.
but then as the field advanced, he seemed to acknowledge its potential, both good and bad.
He had a famous quote about it.
What was it?
He said something like, "Anyone who expects a source of power from the transformation of atoms is talking moonshine."
Okay.
But just a few years later, he also warned that some silly fool in a laboratory might blow up the universe unawares.
Wow, that's quite a shift in perspective.
I know, right?
From dismissing it as moonshine to worrying about blowing up the universe.
It's wild.
It shows just how rapidly our understanding of nuclear processes was advancing at the time.
Absolutely, and that's what makes Rutherford's story so compelling.
Uh-huh.
He was at the forefront of a scientific revolution, grappling with discoveries that would reshape the world.
Right.
He was excited by the possibilities, but also cautious, even a bit fearful of the potential consequences.
It's a reminder that scientific progress isn't always a straight line towards a utopian future.
Nope.
It often comes with unintended consequences and ethical dilemmas that we have to wrestle with.
For sure.
And those dilemmas are still with us today.
Oh, definitely.
The legacy of Rutherford's work is both inspiring and cautionary.
Absolutely.
He opened up a realm of incredible scientific possibilities, but also unleashed a force with the potential for both incredible good and incredible harm.
A double-edged sword.
It's a heavy responsibility, not just for scientists, but for all of us.
Right.
We have to be mindful of how we use these powerful tools
Right.
and make sure we're using them for the benefit of humanity, not for its destruction.
Absolutely, but let's not get bogged down in the heavy stuff.
Okay.
Rutherford's legacy isn't just about bombs and power plants.
Oh, what else?
It's also about expanding our understanding of the universe itself.
You mean like how stars work?
Exactly.
I know nuclear fusion is the process that powers the sun, right?
Exactly. And our understanding of nuclear fusion,
Okay.
the process of combining atomic nuclei to release energy,
Right.
stems directly from the pioneering work of nuclear physicists like Rutherford.
So they figured all that out.
They were the first to glimpse the incredible energy locked within the atom's core.
It's mind-boggling to think that the same forces that power the stars are also at play here on Earth.
I know, it's crazy, right?
In our power plants, our medical technologies, and even in the depths of space.
It really is.
It's like we've tapped into a cosmic power source.
And it's a testament to the interconnectedness of science.
In what way?
Discoveries in one field often ripple out to impact others in unexpected ways.
I can see that.
Rutherford's work focused on the tiny world of the atom,
Yeah.
ultimately expanded our understanding of the vastness of the cosmos.
It's almost poetic, isn't it?
It really is.
The smallest and the largest scales of the universe linked by these fundamental principles of physics.
It all comes together.
And it all circles back to that insatiable human curiosity that drove Rutherford and countless other scientists throughout history.
For sure.
Their drive to understand the world around us, to unlock the secrets of nature,
Right.
has led to some of the most transformative discoveries in human history.
It really is remarkable.
And it's a journey that's far from over. The field of atomic and nuclear physics continues to evolve with new discoveries and applications emerging all the time.
Absolutely.
So as we conclude this part of our deep dive, I want to leave you with this thought.
Okay, what is it?
How will you contribute to shaping the future of science and technology?
That's a great question.
What role will you play in ensuring that these powerful tools are used for the betterment of humanity?
It's something we all need to think about.
Welcome back for the final part of our deep dive into the atom.
It's amazing how exploring something so tiny can lead to such huge ideas.
It really is.
From the structure of the atom itself to the power of the stars.
I know, it's incredible.
It's all connected.
And today we're going to wrap things up by looking at how Rutherford's legacy lives on today.
Sounds good.
You know, it's kind of poetic.
What is?
We started with this incredibly tiny world, invisible to the naked eye.
Yeah.
And now we're talking about stars, medicine, energy, things that affect everyone on the planet.
It just goes to show the power of fundamental scientific discovery.
How so?
Well, Rutherford wasn't setting out to revolutionize medicine
Right.
or create new energy sources.
He just wanted to understand things.
He was driven by pure curiosity,
Uh-huh.
a desire to understand the building blocks of the universe.
Makes sense.
But those fundamental discoveries had ripple effects that continue to this day.
So where do we see those ripple effects most prominently today?
Well, let's start with medicine. Rutherford's work on radioactivity paved the way for some of the most transformative medical technologies we have today.
Like radiation therapy.
Exactly.
I know that's used to treat cancer,
Right.
but I'm not exactly sure how it works.
It uses precisely targeted beams of high-energy radiation, like X-rays or gamma rays,
Okay.
to destroy cancer cells.
And how does that work?
These rays damage the DNA of cancer cells, preventing them from dividing and multiplying.
So it's like a microscopic weapon targeting those rogue cells.
Pretty much.
That's incredible. And I know there's also nuclear medicine where they
Yeah.
use radioactive substances for diagnosis and treatment.
Exactly. Think of PET scans, which allow doctors to create detailed 3D images of organs and tissues.
Oh, wow.
They inject a small amount of a radioactive tracer into the body,
Uh-huh.
which then emits positrons.
Okay.
These positrons interact with electrons in the body,
Okay.
producing gamma rays that are detected by a scanner.
So what does that tell them?
This allows doctors to see how organs are functioning and pinpoint areas of disease.
It's amazing how something so tiny and invisible, like a radioactive atom, can reveal so much about what's happening inside our bodies.
It's pretty remarkable.
And it all goes back to Rutherford's work on unraveling the mysteries of radioactivity.
And his influence extends far beyond medicine.
Oh.
Nuclear energy, for all its complexities and controversies,
Yeah.
remains a significant source of power in many parts of the world.
It's funny to think that Rutherford initially doubted the practicality of nuclear power.
I know, right?
Remember that quote about moonshine?
Yeah,
But then just a few years after his death, the first nuclear reactors were built.
it happened fast.
And now we have power plants generating electricity by splitting atoms.
It just goes to show you how unpredictable scientific progress can be.
Absolutely.
Sometimes those fundamental discoveries open doors we could never have imagined.
And speaking of unimaginable, Rutherford's work also played a key role in our understanding of the stars.
Oh yeah, definitely.
Remember that the sun and other stars are powered by nuclear fusion.
Right?
The process of smashing atomic nuclei together to release energy.
Exactly, and our understanding of fusion stems directly from the pioneering work of nuclear physicists like Rutherford.
They figured all that out.
They were the first to unlock the secrets of the atomic nucleus and realize the incredible energy it contained.
So the same forces that make the sun shine are also at play here on Earth.
Yeah.
In our power plants, our medical technologies, and even in the depths of space.
It's mind-blowing.
It really
It
is.
really highlights the interconnectedness of the universe.
In what way?
From the smallest scales of atoms to the vast expanses of stars,
Yeah.
the same fundamental principles of physics are at work.
And it all traces back to that insatiable human curiosity that
Okay.
drive to understand the world around us.
Uh-huh.
Rutherford's journey reminds us that the pursuit of knowledge is an ongoing adventure.
For sure.
And it's not just about scientists and labs, it's about all of us asking questions, exploring new ideas. and embracing the wonder of discovery.
Absolute.
Who knows what incredible secrets of the universe are still waiting to be revealed?
It's exciting to think about.
It really is. And on that note, we come to the end of our deep dive.
I've got a great journey.
We've journeyed into the heart of the atom,
Yeah.
explored the groundbreaking discoveries of Ernest Rutherford, and seen how his legacy continues to shape our world in profound ways.
It's amazing how much one person's work can impact the world.
It really is. We hope you've enjoyed exploring this fascinating world with us.
Me too.
Be sure to check out the show notes for more resources and information.
Okay.
If you'd like to delve deeper into any of the topics we've covered.
Sounds good.
Until next time, keep exploring, keep asking questions,
Yeah.
and never lose sight of the wonder and beauty of the world around us.
Great advice.